Simplify negative 3 plus 6i minus parentheses negative 5 minus 3i minus 8i. What is I? Well, I is the square root of negative 1, which means you're going to treat it like a square root, which means when you combine like terms, you treat it like a regular old variable. Okay, so what I can do first is I can distribute the negative, right? So that gets me negative 3 plus 6i. The opposite of negative 5 is positive 5. The opposite of negative 3i is positive 3i, and then you have minus 8i. All right, really things should be in the form a plus bi, so you have your real root first, and then you have your complex root second. So let's combine the numbers first. Negative 3 and 5 combine to make 2. Then you've got 6i plus 3i, which is 9i, minus 8i, which is just an I. So 2 plus I is going to be my simplified answer to that. Simplify 4i times the quantity negative 2 minus 8i. Before I get this started, let's remind ourselves what I is. I is the square root of negative 1. It's imaginary. So if I were to take I squared, you would be squaring this square root, which cancels each other out. So I squared is negative 1. So there's I cubed and I to the fourth, but we're not going to worry about that for this problem right here. We're just going to go off of these pieces of information. Let's distribute 4i to negative 2 and 4i to negative 8i. So 4 times negative 2 is negative 8. I comes along for the ride. 4 times negative 8 is negative 32. I times I is I squared. Okay, you're not going to simplify negative 8i. You can't do anything about that. But I squared is negative 1. So why don't we turn I squared into negative 1? Okay, so negative 8i is still negative 8i. 32 times negative 1 is still 32. Don't know why I put an equals there. Should be a plus. So plus 32. And if we're going to write things in the order that it should be, typically these things are in the form a plus bi. So let's write that out as 32 minus 8i. It's not the end of the world if we don't do this, but I'm going to try to be as proper as possible. But now things are simplified. If we had I cubes, if we had I to the fourth, then we'd do more, but we're not going to worry about that, not for this problem. Simplify negative 2 minus I in parentheses and 4 plus I in parentheses. Before I get started, a gentle reminder that I is the square root of negative 1, which means if I ever get to it, I squared would be me squaring the square root, which cancels each other out. So I squared is negative 1. Now there's also I cubed and there's also I to the fourth, but in this problem we're not going to worry about that because this is a FOIL. And with a FOIL, we're not going to go beyond I squared. So let's FOIL it out. Negative 2 times positive 4 is negative 8. Negative 2 times positive I is minus 2i. Negative I times 4 is negative 4i. And then negative I times regular I is going to be negative I squared. So there's two things that we can do right now. Thing number one is we can combine like terms. Okay. So negative 2i minus 4i is negative 6i. At the time being, negative 8 stays there. But I squared, again, is negative 1. So this becomes minus negative 1. So we can clean this out to, okay, well, negative 8 minus 6i minus negative 1 is plus 1. And then you should realize that these two guys combine. Negative 8 plus 1 is negative 7. And then we have minus 6i. And that's the order that I'm going to leave it in because when you're dealing with imaginary numbers, you want to have that number second and then the real solution or the real number first. And that's what we end up with. Find the absolute value of the complex number. The absolute value means distance. So I give you something like this in the form a plus bi. You finding the distance of a complex number is going to involve Pythagorean theorem. Now in future videos you're going to see me graph these, so maybe that'll make sense of this all, but this is going to be Pythagorean theorem. Okay, your distance, your absolute value is going to be the square root of a squared plus b squared. So what I'll do is I'll label you a and I'll label you b. So the distance is going to be the square root of negative 5 squared plus negative 5 squared. Okay, it's nice that they're the same. So you become the square root of 25, because negative 5 squared is 25, plus 25, which is the square root of 50. You know that I can change the square root of 50 into 2 times 5, right? So I can bring out a pair of 5s, and that leaves me with 5 root 2. So absolute value of a complex number is just distance. And again, in future videos, when you see me graph this, maybe this will make a little bit more sense when we put 2 and 2 together. Find the absolute value of the complex number 8 minus 3i in the absolute value. Now, the absolute value is the same as distance, right? This is going to be graphed as if it was a regular coordinate on a coordinate plane. We'll do that in later videos. So right now you might be like, huh? Well, when you see those videos, maybe all of this will make sense. But if you're trying to find a distance of a dot on a coordinate plane, you are going to use Pythagorean theorem. So if I give you something in the form, the absolute value, a plus bi, and I ask you to find the distance, you're going to do a squared plus b squared underneath the square root. Okay, that is Pythagorean theorem. So I would label you a, I would label you b, and I would set up the square root of 8 squared plus negative 3 squared. And then it's just, square root stuff that we have to deal with. You become 64, you become 9. Adding these together, you become the square root of 73. And you can't do anything with the square root of 73. Maybe you could throw that in your calculator and get, 8 point something? But I'm not going to go that far. You can't do a factor tree and do stuff because I don't think you can. That might be prime. I don't know. But that's it. That's our answer. That's the distance. So in the next videos when we graph these, you'll maybe be able to see what that means to find the distance. Graph the number in the complex plane. This is the complex plane. Your x-axis is your real number. Your y-axis is your imaginary number. Okay, that is my real number right there. And the number attached to the I is my imaginary number. That's not how you spell imaginary. That's how you spell imaginary. Now, if you're wondering, how do I graph this then? Is it as simple as going left 3, up 4? Yup, that's literally as simple as it is. Since the real number is negative 3, we go left 3. Since the imaginary number is positive 4, we go up 4, and that is going to be our point on the complex plane. Don't overthink it. In previous videos, when we were asked to find the distance of the absolute value, okay, if you're wondering well, why did we do Pythagorean theorem? Well, because you would view it as a triangle going left 3, up 4, and so your distance is finding the hypotenuse. Okay? We're not doing that here. You can watch those videos. But yeah, that's how you graph a number in the complex plane. Don't overthink it. It's not bad. Graph the number in the complex plane. We have 2 plus 4i. Now, a complex plane replaces your x-axis with the real axis and your y-axis with the imaginary axis. If you're looking at this and saying, all right, well, the imaginary number is the number attached to I, correct, and the real number is the number attached to nothing, correct. Is this as simple as going right 2, up 4? Absolutely. That's literally all it is. Positive real goes real to the right. Positive imaginary goes up 4. That is my point in the complex axis. Don't overthink it. It's just graphing a point. Not bad at all. Name the conjugate of 2 plus 4i. If I give you something in the form the complex number a plus bi, its conjugate is you simply flip-flopping the sign of the imaginary number a minus bi. So the conjugate of 2 plus 4i is literally 2 minus 4i. Don't overthink it. Easy stuff.